All right, we've been working through our worksheet talking about arc length and sector area, and let's go down towards the bottom of the front of the page. And so we've got our formulas here. So the circumference gives you the length of all of the outside of a circle, and the area gives you the area of all of the inside of a circle. But what if you only wanted to measure a part of the circumference or area? So let's say we only had this part of the arc that we wanted to measure, or let's say we only had this sector. Looks like a slice, but the official term for this is a sector. So what is the area of this sector? And does it have something to do with the total circumference and total area? So what I want you to do is I want you to pause the video. I want you to look at the clues that we have here. I want you to look at these formulas, which I put at the top of this page for a reason, because we're going to use them down here. And I want to see how far you can get in this problem on your own. All right, hopefully you did that. So let me go through this the way some of the students in class did this. All right, so they were thinking to themselves, well, this is kind of like the circumference. So why don't I calculate the circumference of a circle? So I know from this diagram that the radius is equal to 9. And I'm looking at the formula for the circumference, but I need to know the diameter. And they don't have a diameter listed here, but I know this relationship that the diameter, if the radius is 9, then the diameter has to be twice as big as that, which is 18. So now that I know the diameter, I can put it into this formula and see that the circumference is, we're gonna just write that as 18 times pi. We could multiply 18 times 3.1415927, blah, 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 and get a kind of precise number, as precise as we wanted, but this is an exact value, so we'll stick with this for a while. All right, now that's useful information. It must have something to do with this problem, but there's a fact that we haven't used yet, and that's this 120-degree central angle that subtends the arc we want to measure. Okay, so an important question to ask yourself is, how far is it all the way around the circle? How many degrees are there in the full circle? Well, I think you know that one. It's 360 degrees. So if we thought about it, 120 degrees divided by 360 degrees, we can simplify that fraction. It becomes 1/3. And so that kind of means that 1/3 of the entire circle is taken up by this central angle. And because of that, can you think about the relationship between the entire circumference of the circle and the length of the arc we're trying to measure? Well, it's going to be the same relationship, that this length is going to be 1/3 of all the way around the circle. So the arc length, I'm going to take 18 pi and I'm going to multiply that by 1/3. And so that's 18/3 times pi. And I can simplify that because 3 goes into 18 6 times. And so there is my final answer. If I want to leave it in terms of pi to have an exact value, the length of this arc would be 6 pi. All right. So in the next video, we're gonna answer the same question for the other problem. So take a look at it first, maybe grab a sheet of scrap paper and see how much of the same process you can carry over to talking about that second problem, because it's going to be a very similar format, but there are going to be a few key differences along the way. So see if you can track down what they would be.